So, quiz preview. Couple of notes here at the start. On the front, the biggest thing for some of you on these first 4 questions is going to be being careful on watching what symbol is between your parentheses, if there is a symbol. If there's a plus or a minus in between, you are not multiplying these out. I do not want to see a 4 by 3 box on number 1. I do not want to see a 3 by 3 box on number 2. All you're doing is combining like terms. And here you just have to distribute the negative through. Okay? Nothing complex. Number 3, you do have to multiply through. Whether you're setting it up, some of you are still comfortable with FOIL, and well, not FOIL on this one because there's a trinomial term, but you'd be comfortable distributing. For the rest of you, again, the nice thing about setting it up this way is once you fill in all the information inside, it's even set up for you with like terms and degree order, and it's nice. So again, multiply to fill the box, then add from there. Now number 4, I'll admit it. I'm going to say it. I'm going to try and save myself some physical pain. They thought this was funny first hour. This is not, okay, not x cubed minus 27, and I'm done. Okay? No. I see that on the quiz, I'm going to start banging my head against the wall. And I literally hurt myself one time doing that. So, we're not going to do that. We remember, this can be done one of 2 ways, and I don't care which way you do it. Okay, you have 3 quantity x minus 3. You can either take them a pair at a time and FOIL or box them out. So like if I were to FOIL or box out these first 2, I'd get x squared minus 6x plus 9. And at that point then, I would take these last 2 and set it up just the way I did this. I'd have a 2 by 3 box that I'd fill in and combine my like terms. Okay? That can take some time. You also have to be very careful with what you're doing with your signs and things like that. Your other option, if you remember back when we were doing Pascal's triangle, would be to sit there and go, oh yeah, it's that one where we got to the third, and the one with the third is this 1, 3, 3, 1 thing. So if you were to go that route, and remember, that was just where I did a cubed and kept going down until I ran out of a's. And then I started with the b's at the other end and started working down until I ran out. And then I just used substitution. So like here, x would be my a term, -3 would be my b term. So basically I would have x cubed plus 3, again my a term is just x, b is -3, plus 3 a b squared plus b cubed. And again, oops, I went off the screen. But again, it's about if you feel comfortable in building, your binomial expansion, that's fine, but I'll get the same answer once I simplify here, 9 times. This would be the same answer I would get if I just multiplied these 2 out. No right or wrong way. Pascal's triangle can go a little faster sometimes if you know it, but if you don't know it and you want to take the safer method, that's fine. Again, no big deal. 5 and 6, you're just substituting the value in parentheses in for x and simplifying it. That shouldn't be a real big deal. And you will have all the answers before you go. Yes, ma'am. Yeah, I was going to say, you could box that, and then you could take this and box it just like you. Yep, you absolutely could. Yep, you could box the first 2 together and then box that with the third one if you wanted to. What would be what? You mean like when I'm setting up a box for this? Okay. Yes, ma'am. Because I'm a bonehead and it's minus 27. I said I did 4 cubed instead of 3 cubed. Thank you. That's the worst thing about this. Now I'm forever start online that 3 cubed is not negative 54. It's minus 27. I should have seen that here too. 7 is going to be a doozy, I have a feeling. 7, especially for some of you that skipped number 64 when we were doing the homework on these. Post this up a little bit. Senior class is selling t-shirts for a prom fundraiser. The class is selling the t-shirts for $12.50 each. The shirts cost the senior class $60 for the design print plus $4.50 per shirt. When you're in business and you're trying to figure out how much profit you're making, how do you figure that out? Yeah, here I need to know my sales or my profit minus my expenses. So when I go to write the profit function, my profit comes, so I have $12.50 per shirt. So that's going to be variable. I might sell 1 shirt, I might sell 500, who knows? Minus my expenses are $60 for the print, plus $4.50 for every shirt. Now, could I leave it that way? Sure. But if I wanted to simplify it and make it a little bit easier to actually calculate this, I could distribute that negative through. So I'd have 1250x minus 450x, which would be 8x minus 60. So basically what that'd say is I'm $60 out to start, but I'm going to start making $8 every single shirt once that's paid off. And then to find the profit, depending on which version of the profit function I have, I'm just going to replace the x, maybe use t for t-shirt, with the 125, and then just work that out. So it looks like I'm $940 ahead. But it's just like 64 in that you take your two variable expressions, and in this case, since I'm trying to find how much money I made, I subtract the expenses, but you just want to watch the wording to see if you're going to add or subtract. Okay? Yep, 940. Okay? Okay, so I'm distributing this through. So I just did the 1250 minus 450 and the 60. I didn't have anything to combine it with. What's that? Yeah, because I was subtracting my expenses. So yeah, so negative is going to be on the 60 here, and then the 450. But then I can actually combine like for my 8 coming from. When we get down into here again, be careful of what you're being asked to do. You have both of your functions. So there's a difference between, like, let's say 9 and 10 here at the start. 9, I'm multiplying f times g. Notice no numbers. And if you wanted to set up a box for that, you could. But otherwise, just distribute the 4x through to both terms, not just the first one, and be done. Okay? No fancy business here. This isn't 36x to the 5th. X to the 3rd and x squared have different exponents. Therefore, that's as far as you can go, as far as getting those put together. However, 10, there's my open circle. There's my f of g of x. And this is just like what we were doing on the worksheet from Friday, where g of x is this actual function 2x plus 7. Because then, here's f, 4x squared. So this is going to be 4 2x plus 7 squared. And again, if you see squared, if you see cubed, anything outside of these, you've got to FOIL this out, box this out. Don't just distribute the squared. So like for instance, once I boxed this out, or FOILed it out, here's what it would look like. And again, don't just write mine down, work it out yourself and see if you get the same thing. This is what you should get when you have multiplied your binomial out. 4x squared plus 28x plus 49. And again, the 4 is just ignored then. You've got to distribute that through. And then you have your f of g of x. Are you sure? I think that's a good question to answer, and I answered without even opening my mouth. Oh, yes, ma'am. Sure. Let's even go back to 5 here. Move this down just a little. I think I can still squeeze. There we go. Okay. Basically, straight substitution. So I've got -2, and then times the absolute value of -4 and -3 plus 3. Now again, absolute value is different than parentheses. I've got to simplify everything inside the absolute value and then simplify that. So, negative times negative will be 12 plus 3, which would be 15. But the absolute value of 15 is still 15. And I just finished off. And it'll be the exact same deal going on in 6. I'm just going to replace each of the x's with a -1 and simplify it to get to my answer, which for number 6 should be 7. So if we've got anything different for that, we'll have to see. Right, yeah, we're not, no boxing here. No boxing. And actually, there's a couple of things on 9 and 10 I need to talk to you about still, but I'll hang on to that for just a second. Yes, sir? No? Okay. Mentioning here on 8 through 11, state any domain restrictions. You have to tell me if there are. Now remember, there's only 2 things that can mess up your domain from being all reals. You can't have 0 in the denominator of a fraction. So as long as you don't have a fraction, like 9 or 10, that's not a big deal. And 2, your even roots have to be greater than or equal to 0. Remember, so like if you have the square root of something, that has to be greater than or equal to 0, or it's imaginary. You can't do imaginary numbers in the calculator. We get error messages. We're just dealing with real numbers. Or if you had something to an even root, because remember, even in an exponent, if I get a fraction and it's got an even denominator, that's an even root. So those are the only 2 things I have to be careful of. So 9 and 10 are both all reals as far as my domain goes because, well, there's no fractions and there's no radicals. That's all good. However, if you get to 11, and I put f of x over g of x, first question, can I simplify that anymore? Like, can I wipe out the 4 and 2 and just call it x squared over x plus 7? Kevin's trying to concuss me. No. Unless you can take something out of all three terms. That's as far as that goes. But, do I have a restriction issue? Yes. 2x plus 7 cannot equal 0. Otherwise, this is going to be undefined. So I'm going to solve this just like I would solve an equation, except that I want not equal to. So for this particular restriction, I'd have all reals not equal to negative 7/2. One number out of all the numbers possible causes a problem, and that's it. So I'm not going to allow that one number to be included. And then 12 actually is just like the homework assignment from Friday. I'll give you the answer. Okay. Number 12 should be 20 when you get there. When you get there. All right, we'll see. I bet you it's an issue. Well, I bet you I know where the issue is, but we'll see in a second. I bet you it's just a sign problem. All right. Oh, yes. Okay. Correct. Right. When you're rewriting these, or like if you were labeling them, these are just labels, letting you know what you're doing. That's not part of the problem. That's not something I'm trying to get x by itself or anything like that. What f and g are doing, and if there happens to be something in the parentheses that you're doing. So like when we did f of g of x, now that x has become 2x plus 7, it's just letting me know what to plug in. But yeah, as far as solving anything, that doesn't have anything to do. It's just telling you where to put things. Okay. Back. I will come back over to that if we need to take a peek at how 20 is coming to be. All right. 13 and 14. I'm going to make a confession here. This is a situation, rare as it may be, if one of your functions is an absolute value, plugging in the number ahead is a good idea. Like, well, what do you mean? Here's what I mean. For instance, let's say we're doing 14. Find q of p of negative 3. Okay. So q of p of negative 3. What I'm going to do is I'm going to plug in the negative 3 into my p. So let's see. 3 times negative 3 would be negative 9. Minus 6 is negative 15. But what's the absolute value of negative 15? Positive 15. So this is really q of 15. Because when I did my p of negative 3, I had 3 times negative 3 minus 6. And I simplified this. And that's what got replaced in where this p of negative 3 is, because I found its value out. Once I did, q of 15 means I'm just going to replace the x with what's in the parentheses. So the only thing that's changed between these two things is that the x is gone, and what's in the parentheses here is gone in for it. 15 squared is 225, times 2 is 450, minus 3 is 447. But you notice I'm still working from the inside out. I start in, did my p's, and then that answer I plugged back in for q. It's just like doing a double substitution, basically. That's what we're doing. So then, since I got 15 over there, I'll jump to 16. 16, now you have options. If you so choose, you could just plug some values in for x, and try to work that out that way, but here's my plan. I'm going to bump up a little here and try to avoid some glare. You can just go to your y equals and type this in on the calculator if you wanted to. Make sure you get all your signs right. So x to the third minus 2x squared. Okay. So here's my graph. Now, since I'm just looking for a sketch, a little bit, so now here's what I still would do. I'd still hit second and graph and bring up the table because I like to be as accurate as I can here. Now, this is not a parabola. It's nothing like a parabola. So you're going to get some numbers that are kind of strange. So seeing the picture to kind of guide me is going to be a good thing. Okay, so that looks pretty decent in comparison to the picture that I see. When I'm doing domain and range, remember, domain is easy on these. This graph is going to continue to expand outward in both directions. So that's where the negative infinity to infinity is coming from. It's going to go forever. It's going to stretch both ways. What about my range, though? I'm going from the bottom of my graph, which I can't even see because it's going to keep coming down here, to the top. So what would my range interval notation be? Yeah, it's going to be the same. Because I don't have a top or bottom point because it keeps going forever down. It keeps going forever up. So domain will always be this way, but my range can change depending on what my picture looks like. And then the end behavior that goes with that, remember, we're always looking at x, each of the ways it goes. So for instance here, okay, as x approaches negative infinity, okay, let's think of it in words. As x goes left, what happens to y? So as x goes left, what's happening to y? It's going down, which, how do we signify down? Negative infinity. So if you need to write it out verbally to start, you know, as x is going left, y is going down, and then put the infinity, the proper one with it, that's fine. Same here. As x approaches positive infinity, so as x goes to the right, what happens to y as x goes to the right? It goes up to positive infinity. So it's going like this. It still would be the same thing. But instead, if it were going up this way, here where we had the negative infinity before, as x is going left, if y were going up, this would be positive. So like if I were to take this graph and flip it upside down, these would just switch. Okay? So that's one thing we got to kind of play with. Then the three on the bottom. I picked three problems that were most often missed on the chapter test, and here they come again. So we can go over this again. Yay! So, when we get to 17, 18, and 19, I will do all three of these with you. I cannot have I in the denominator. That's a no-no. Well, I can't quite just take the I out this time. What do I have to multiply by to get rid of it? Okay, 2 minus I. I have to take what's called the conjugate, which just means you change the sign in the middle. You don't change the sign of everything, just the sign in the middle, and then you box or FOIL each of these out, and it'll simplify into the answer we're looking for. So again, if I were to box or FOIL this out, here's what my numerator would look like. So for those of you boxing, this would be my box before I combine like terms. It would be my filled-in box. And then down in the denominator, this is what my box would look like on the inside with its terms before I got to the simplifying part. Now this is a good start, but I'm not done. Once I've multiplied this out, there's a couple of things I can do to make this a little more simple. For instance, what does I squared equal? Okay, -1. So wherever I see an I squared, I'm going to replace it with a -1. So 2 times -1 is -2. I'm literally going to cross that out and replace it with -2. And then -1, you can look at it that way. -1 squared is 1, but then there's the minus there. So that gets put in there. Okay. Oh, gee. Hardy. They're like, Hardy, what are you doing? I'm like, oh. Yeah, minus a -1 would be +1. That is for certain. It's the first day of the week. Oh, gracious. So, as I start to finish off my simplifying, I see that -2 and +2i are going to cancel. So 4 plus 1 is 5. Success there. I don't have any i's left in the denominator. 8 minus 2 is 6. -4 and -4 is -8i. This one's done. If I'd have had something that came out of all three terms, I could have done something with it. Okay? Finish them off here. What's that? Okay. Here, before some of you want to square root this, you have to get the 8 out of there. So add it over. I still can't square root this. X squared isn't alone. So divide by -3. And here's the kicker. When I take the square root, in this case, two things. One is plus minus. When I break down my radical, it's 2 square root of 3, but there was a negative there. Don't forget to pull your eye out. But you have to have x squared isolated before you can square root it. And the final thing. If you're trying to use vertex form when you're completing the square, most of you were good on the test and remembering, oh yeah, it's -b divided by 2, and I square it, and that's what I add to each side. Here's where the dilemma came in. This becomes a perfect square binomial. I either steal the number from when I did b divided by 2, or what multiplies to 16 and adds to -8, -4, and -4. And to complete my vertex form, I just get y by itself by minus into 16. My vertex would be a 4, -18. So what you see in front of you is what we will be dealing with tomorrow on this quiz. And then we're going to kind of jump back into some stuff with factoring and functions and things like that. So this will be on the website tonight. If you need to go back over anything, I would suggest highly, if there's parts you're struggling with, okay, do some odd book problems, or maybe I've got the blank of this online, copy this off, see if you can do it without listening or watching or anything, but be ready to roll with this tomorrow. Yes, ma'am.